We all are.
Okay, so you should have a paper like this. Leave those cards out because we're going to do something with them again later, so don't put them all the way away. You're going to need them in a few minutes. So you should have this half sheet of paper in your notebook or in your folder. So you'll notice we are now talking about quantitative distributions. What does quantitative mean? You can find an average. These are measurements. They're numerical values that mean a quantity. Okay? It's a measurement. So when we are describing them, there are certain characteristics that we need to include. So this acronym of SOCS is going to help you remember all of the things you need to include when you're describing it. Okay? So we're going to go through each part. The first S is for shape. So that's why we were talking about shape with your distributions. So there are 3 shapes that we use a lot, but then there are a few that we don't see very often, but you need to be aware of. So we're going to talk about each of these. So this first one, hopefully one of your groups looks something like this. Taller in the middle and kind of gradually going off each side. Okay. Did you guys have a group with this sort of shape? Yes. Good. So give me some of your ways of describing this shape. What are some of the phrases you use? Parabola? Okay. Arch? Parabola. Which? Pyramid? Do you guys have one back here? Chad? You guys can have one? Parabola. Okay. Take back here. Group number 2. The smart guys. You guys coming good? What did you come up with to describe this? So it's like a hand. It's got the fist. Okay, so here's the word we are going to use. Oh my gosh, wait a minute. Symmetric. We're going to say this is roughly symmetric. So if you think back, whenever you're in geometry, you probably talked about symmetry. Okay. Some of your other math classes, depending on your background, we have lots of backgrounds here, but you've probably heard of the symmetry before. That's what we're looking at. It's roughly symmetric. Doesn't mean it has to be exactly mirror images, but it's pretty close. Okay. It's taller in the middle and gradually goes off each side. That's going to be our idea of symmetric. Okay. Our next shape, let's say it's taller on this side. And it goes off a lot slower on the left than the right. So this is one where it trails off farther on the left than the right. Did you have one similar to this? Yeah. A group that was kind of like this. So this one we call skewed left. It's which side does it go out farther on? That's the way it's skewed. So this one is longer out on the left, so it's skewed left. So what do you think our next one's going to be? You are correct. So this one's going to be taller on the right and skewed to the left. Okay, these three are the most common shapes that we will deal with. Rarely do we have one that doesn't fit one of those three. Okay? So when you are creating a graph and describing it, you need to realize these are going to be the more common. Don't try to force it into one of these other ones that we're going to talk about, because they are rare, but you need to be aware of them. Okay? So these are the three used most often. This next one, so this one, they're about all the same height. Okay. Did you guys have one like this?
Yeah.
What did you call it?
A mask.
Just a mask? Level?
That one.
That one. That one. Okay, we have another word for it than that one. It's uniform. It's uniformly distributed. It's the same all the way across. I want to get somebody saying that one on the test. Okay. Okay. So this one, rare. Doesn't usually happen. It's going to be one of these three 95% of the time. Okay, the other one, we have one more. Does anybody have a guess what the other one is?
The random one where they're all
Miscellaneous. They're everywhere. Okay. My first hour had the best description of this. They were like, it's the whoosh one. I was like, I like that. The whoosh one. Yeah. This one, there's a tall part over here, and there's a tall part over here. Exactly. The field goal. So it's taller on the outside, but shorter in the middle. Okay. So it's kind of like a half pipe. Oh, it is? So this bimodal. There's a mode over here and a mode over here. Okay, so there are two peaks and a valley in between them. Here's the thing. People try to make this when it's really not. They will look at this and go, well, this is a little shorter than these two, so that's bimodal. No, it's not. Don't force something to be. Just because this one's a little bit taller than that one doesn't mean now it's bimodal. Okay? Look at the overall shape and what is it doing. Okay? It needs to be pretty far apart and really short between it to be bimodal. This is rare. Rarely do we see this happen. Most of the time, listen. Most of the time when we see this, it means we should have split up the data. Think about this. If I were to look at student heights, I may get this type of distribution. Why? Male and female. We're going to have, guys are usually taller than girls. So we're going to have this group over here of girls, the group of guys. You're going to have different heights. So that means I probably should look at them separate. Okay? I love that the microphone's picking up everything you guys are saying. So I can email it to your parents and go, listen to what your daughter did in school today. This is what she did. So, here's the thing. If you get a bimodal distribution, you should be thinking, did I need to split up this data? Was there a problem with the way I did it, or is this just a bimodal distribution? Most of the time, it should have been split up. It would be more meaningful to look at male heights separate from female heights than putting them together. Okay? So that would be more productive. So those are our 5 different ones that we're going to look at. Those top 3, those are the ones you will use most of the time. Don't try to force it to be one of these down here. Most of the time it's going to be one of these 3. Okay, questions on those? Alright, now we're going to the O. O is for odd features. So when we're describing a distribution, if there's something that's strange about it, you want to make a note of that. Okay? So
I'm ready to be off.
I can't talk over everybody. My throat's killing me. So here we're looking for the unusual things. Things that we normally don't see. That means, are we usually going to have an odd feature? No, because then it would be usual, it wouldn't be unusual. These do not happen all the time. But if they do, you should mention it. Okay? Most of the time you won't have one. But if something comes up, you should make mention of it when you're writing a description. Okay? If it comes up, it's unusual. So don't try to make everything fit into one of these. Most distributions don't have any of these. Okay? So some of the things that you will look for. Outliers. Okay? This is an extreme data points that are far away from the bulk of the data. And this can be on either end, on the upper end or the lower end. Either way, you can have an outlier. Next week, we'll look at how do we calculate this. Okay, we'll have some calculations that we do to mathematically tell how far is far away. So we'll have some formulas that we use for that. For now, just know those are going to be the far away points. The other thing that we'll look for, is there a peak or a valley or a gap? So in other words, is the data bimodal? So again, that's unusual. You're not going to see bimodal very often. Maybe once or twice this whole year will we see data that is bimodal. It's not going to happen very often. People try to make everything be bimodal, but it's not. Okay? So that would be an unusual thing. If it were bimodal, you would say there's a peak at this x value, there's a peak at this x value, there's a valley between this value and this value. You would describe those attributes. Okay? Are there some gaps in the data? So, do we have some values where we don't have any data? Did we have test scores between 80 and 100, and then we didn't have any in the 70s, and now we have some in the 60s? Okay. Was there a skip in some values? Did we leave some things out? So we would mention that if there are any gaps in the data. That's going to be pretty much our odd features. Those are going to be it. We don't have a lot of different things to look for, but we need to make note if some of these happen. Okay, so the next one, C, this is for our center. So these are going to be the ones you are probably most familiar with already. Mean. What's another word for mean? Average. So we will just add all data values and divide by the sample size. This one you guys should be super familiar with already. Next will be the median. This is the middle. Middle value when everything's in numerical order. What do we think the third one is? Mode. The mode is the most. So it's the data value that occurs most often. So those, we will use each of those for specific reasons. There will be some times that we use mean, sometimes we use median. And it's going to depend on the shape of the distribution, and we'll talk more about that later. But just realize we will use each of these, but they each have a specific use, and you need to make sure you use the appropriate one for each circumstance. Okay, last S is for spread. So our first measure here you should be familiar with as well is the range. So to get the range, we'll do the maximum value minus the minimum value. Range is a single value. Do not say the range is 5 to 25. Nope, the range is a number. It's one number. It should not be, it goes between two numbers. If it's from 5 to 25, your range is 20. So that one we use sometimes. Usually we'll talk about range if they just give us a graph sort of like what you had on your cards that you were sorting. where you don't know the data values, but you have a graph of what they look like, and you can tell about what is the minimum and maximum, then we may use range to describe the spread. Otherwise, we want to do a computation to get a more specific value than just the range. One of them that we use a lot is the interquartile range. We abbreviate that as just IQR. Anyone ever heard of that? Nope. Awesome. We'll use it a lot. You'll know it well. This is the range of the middle half of data. And this is also a single value. So what this would look like, put all your numbers in order, least to greatest. Find the middle, that's your median. That median is the 50th percentile. It's halfway. You have half the data below, half the data above. Okay, 50%. If I have found the middle, and I found the middle of each side, now I've got that in 4 parts. Those are my quartiles. Okay, so first quartile, second, third, fourth. I've got it into 4 pieces. Okay, the difference between these two, 50% of my data is here. That is my IQR, is subtracting these 2 numbers. Okay, taking Q3 minus Q1, that gives me IQR. Okay, we'll talk a lot more detail about that, but that's kind of what you're getting to with interquartile range. The last one we're going to talk about here is standard deviation. You will learn to love it.
It really screwed me because I did the first thing that was yeah, I'm gonna screw you. Yes, and
So roughly the average or typical distance each data value is from the mean. So an example of standard deviation, think of it as though we just took a test last week. We had our multiple choice and our free response. Let's just say I tell you the class average on the free response is 43 out of 50. Okay? So let's say the class average is 43 out of 50. So each of you could then take the grade that you made and find out how far you are from 43. If each of you did that and got your calculation, if we took the average of all those, that's our standard deviation. Okay? So find out how far each one is from the average, and then find the average of those numbers. That's standard deviation. The good news is you will never have to calculate it on your own. The calculator will do it for you. You just need to have an understanding of what does it mean. Okay? So it's just the average distance from the mean. Okay. Questions on any of those terms? We will go over a lot more detail, but like how to get to it. Okay, think of, I line up all of the values least to greatest. Now find the middle. That middle value, that's my median. Okay? And then I say, okay, for this top half, I want to find the middle of that. Okay? For the bottom half, I'll find the middle of that one. So now I have 4 quarters of the data. Those are my quartiles. Interquartile is what's the difference between these two values. So I'll know what those are, I just subtract them, that's my interquartile range. Because what the idea is, if there's something that's an outlier or some weird value, it's going to be out here at the ends. So this eliminates all the weird stuff and gets us the bulk of where it really stacks up most. Okay, so that's why we use that interquartile range a lot. Okay, in your folder, you have another half sheet of paper that's going on page 50. It says writing descriptions at the top. You're going to use those cards that you sorted earlier to answer these questions. So for instance, on the number 1, it gives you a description. My variables distribution is skewed to the right, no major outliers or odd features. It has a typical value in the mid-30s and ranges from mid-20s to lower 50s. Now when it's giving you those numbers, it's talking about these values at the bottom, the X values. So you're going to look through your cards and you're going to find something that seems to fit. So you're going to say, okay, let's pretend that I thought this fits. It doesn't, but let's pretend I thought it did. If I thought this was the correct answer for what matches that one, I would write test score on blank 1. So whatever that variable is at the bottom, that's what you're writing on the blank for that question. Then just go through those 1 through 5. You're just matching up one of the cards to the description that you have. Then on number 6, it's telling you one to write a description about. Okay.
So we just pick one of these cards